Well, I want to tell you about some things that I've been working on that have kind of come to fruition after basically 30 years of work. Actually, it'll be this August, it'll be 30 years since I started my company, Wolfram Research, and it still feels like a startup even after 30 years. We're always doing new and different things, but we've been building the stack of technology that in recent times has gotten to a very exciting point, a point where I think a lot of people, a lot of other startups can start to do things that are really qualitatively different than's been possible before in the software world. So the thing that I'm mostly going to talk about here is what we call the Wolfram language, which is kind of a merger of the technology that we built in Mathematica, which has been used for the last quarter century or more to make all sorts of inventions and discoveries and so on, and the technology we built in Wolfram Alpha, which is used in things like the Siri Intelligent Assistant and other things, and is also used by lots of people as sort of an everyday question answering system on the web. It's a merger of those two technologies together with a lot of new ideas, particularly about the way that one deploys advanced software on the cloud, mobile, supercomputers, embedded systems, and so on. So this is what I'll talk about. It's something it's been exciting for me to see just in the course of this year, sort of rapid growth in the use of Wolfram language, winning hackathons, startups being based on it, lots of different things happening. Why don't I actually show you a little bit about it? And I'm always, this is what happens if you've run a software company for 30 years. You actually only can do live demos. And okay, let's see. One thing I should say, I'm going to show you kind of at first the desktop version of Wolfram language. Anything that I'll show you here, you can also do in the cloud, and actually as of about a month ago, we now have an open cloud, so you can just go to our website, click on something, and be there live doing things. Okay, let's see. Okay, 2 + 2 works. That's always a good sign. Okay, let's see if something else works. Okay, good. That's also a good sign. So the way that we start off interacting with the Wolfram language is you give it some input, it figures out what you mean, and generates output. There are other ways that you interact with it when you're using APIs, when you're embedding it, and so on, but this is kind of the easy way to see what's going on. So this is so what can we do with Wolfram language? So we can do all kinds of things. The sort of idea of the language is to have it build in as much as possible, build in as much knowledge as possible about how to compute things, knowledge about the world, data, and so on. Most languages are set up to have a language that is small, where the language itself has very little content, where perhaps there are libraries that people have added somewhat incoherently perhaps over the years, but the language itself is small. What I've tried to do in Wolfram language is spend the last 30 years building up this very large, coherent system where all the different pieces fit together, and in particular where we've tried to automate as much as possible. So sort of the idea is you explain to the language what you want to have done, and it will as automatically as possible try and get that done. So for example, we could type in, we could say make a random graph. This is a pretty good approximation to my Facebook friend graph. We could say something like do a computation on this graph, work out the communities in this graph. Okay, we get a result like that. Sort of the idea is we're able to compute with any kind of data, any kind of structure in the language. So let's say we pick up another kind of thing. Let's say we try and get, there we go. Okay, that's not a very good one. Let's try again. Okay, there we go, slightly better. There's an image. Okay, so now we can go ahead and just do computations on this image. Let's say we want to detect edges in the image. There's the result. Or we could say something like, let's dynamically edge detect the current image. So I'm writing a little piece of code here in Wolfram language, and there we get the result, and we can do all sorts of things there. So okay, so we can do all kinds of computations with all sorts of kinds of data. Let's say we just want to make a picture of something. I don't know. We could make something like this. Oops. We could take some data. We could just plot something like this. Okay, great. Now we could say, okay, let me make a little user interface here, and we kind of automate the process of making this user interface. So let's say we put in a parameter there. We can make this, let's say, a parameter like that. We can vary that parameter, do things with it. So again, I'm just putting in this kind of symbolic specification of manipulate this with respect to this parameter. A user interface automatically gets created that allows me to do that manipulation. So okay, The next big thing about Wolfram language is that it deals with things about the real world. So, for example, we can say something like, I don't know, we could say New Orleans, and hopefully if we can connect to the web, let's see, we are using my phone as our connection to the web because that was the fastest solution. If I can't connect to the web, this is all going to be very disappointing. Let's see. Well, my phone says it's alive. That is a good sign. Let me see. What is going to happen if we can't connect to the web? This is what happens if you have a modern cloud-based system. If you can't connect to the web, you are totally hosed. Okay, let's see. Well, why isn't that working? Timed out. That's not a good sign. This should take like 30 milliseconds or something. Okay, what's... Well, I tried connecting to... That was really slow, so we tried connecting to my phone. Anybody got a better idea here? Okay, I'm sure that was what it was connected to before. Let me see. Well, let me check one thing here. Okay, I may need that, but this is, first of all, we have to see whether this is alive at all. Ah, horrifying. Okay, well, it's real life. All right, let's try. Let us try this. Kill this. Come on. Okay, ignore that. Let's try it again. See whether for some reason it could not connect there. Okay, signing in. Okay, that's a good start. Let's see if it signs in. This is a very bad sign. Okay, all right. Let's try something different here. Let's go to our home page, see if we can get there. Sorry about this. Nope. Okay. I'm going to take that person up on their... Let's try connecting to this. Okay, that connected to something. Let's see whether we can go anywhere here. It's incredibly... Oh, I think I'm on there, so let's try this now. That's a good sign. All right. Let's see what happens now. As I was saying, all right, let's try and get some kind of real-world data in here. Let's see if this works. Come on. Very good. Okay. So now, okay, we're alive again. So one of the things that's really important about Wolfram language that really distinguishes it from pretty much every other language that's in common use out there is that it's a symbolic language. So if you just type in X, it says, okay, that means X. It doesn't have to have a value or anything like that. And everything it deals with is just a symbolic object. So this is another kind of symbolic object that happens to represent, you know, a 3D graphic sphere. New Orleans is another kind of symbolic object that just happens to represent a city. And so we can ask it, for example, oh, come on, okay. Yeah, okay, so we can ask it like, you know, what's the population of New Orleans? Or we can say something like, we could say, where is it? Oh, that looks like a weird VPN location. Okay, let's say we want to know something like, let's do something like this. Let's use some other real-world data. Let's make a map. We'll make a disk around the center of New Orleans, let's say 10 miles radius. Let's go ahead and do that. And now we can do this, and assuming that we can pull in the data fast enough, again, this is usually rather much more instantaneous than this. Oh dear. Oh my gosh. Well, it obviously couldn't. That's interesting. That's what it does when it can't get some of the data. That's interesting. It's not too embarrassing. Okay, now I've got a little bit more. All right, good. Anyway, if it had worked, it would have drawn us a nice map of New Orleans. Again, this is all stuff that's sort of integrated into the language. So we could say, for example, I don't know, we could get something like a list of words in English. Again, this is this is the lovely world of sort of close integration of the cloud and other things. But let's say I want to do something like, I'll just write a piece of code here. I'll take the first letter of each of those words, and now, for example, I can make a word cloud that shows me the relative frequencies of different letters in first letters in words in English. So it's it gives you some sense of how you can do, that's a very microscopic piece of kind of data science that we could do here. Or let's say, for example, we could just say, let's get counts of all those letters. Okay, let's make a bar chart of those things with labels on the bar chart. Let's see here. And that will then again just show us the relative frequencies of those letters. So simple stuff, but this is very, very straightforward to do here. And we can deal with all sorts of different kinds of data about things, like let's say we want to have data about, let's say, I don't know, we've got, let's do something kind of cultural. Let's say we have the painter Van Gogh. We could ask, what are some notable artworks of Van Gogh? We could then get some list of things here, and then we could, for example, say let's take a bunch of those notable artworks. Let's take the first 10 of those notable artworks, and then let's figure out images from those artworks. Okay, there they are. And now, for example, we could say let's make a chromaticity plot that shows. Let's see if this works. Yeah, there we go. That shows the distribution of colors that were used in that in those particular paintings of Van Gogh's. So this is kind of the idea is to build in as much knowledge about the world and as much knowledge about algorithms as possible. So another kind of area that where there's a lot of things that we've done is in machine learning, and we've kind of tried to automate as much of machine learning as possible. So for instance, I could go here, let me go to the web and let's search for what's a good, let's try a beaver. How about that? Let's get a picture of I don't know why I picked a beaver, but let's just try, let's try taking one of those guys. I don't know, let's try that guy there. Okay, I don't know what it's going to say here. So now let me say, let's image identify this thing here. And it says it's a porcupine. Oh, well, let's try. Okay, now with that embarrassment, we better see whether we can, I couldn't tell if that's a porcupine or a beaver, so I'm not, it knows about maybe 10,000 different kinds of things. Let's see whether there's let's try that guy there. Okay, that looks more promising. But in any case, we could, if we wanted to, we could get, we could just do a search on the web for something like a beaver, and we'll get out some sort of computable version of that. Oh, great. Let's not wait for this. Oh, maybe we can. Okay. Just to give an example of how we're kind of dealing with data sets, we can deal with data sets of all kinds of sizes and shapes and so on. This should bring us in some, if it wakes up. Come on, web. Well, okay. It should bring us in a nice data set that we could then play with. Okay, there we go. So let's say, for example, we just take the first pictures, let's take that, and let's take all the first things there, and let's just get a list of them. Okay, there are a bunch of beaver pictures, and now we could, for example, say, I'm just showing you how you kind of write the code here. You could say, make a column, oh no, let's just label each picture. Again, this is just Wolfram language code. Label each picture with the image identification of that picture, and let's try doing that. So now it will run that. Okay, so there it'll say different kinds of things about what. Okay, that one it thought was a person. That one it thought was a hippopotamus, which again, not so foolish. But in any case, this just gives a sense of what's going on, and you can train your own machine learning classifiers and so on. In fact, we will soon have a very, very beyond state-of-the-art kind of framework for doing that. Right now, we have a very automated way to let you sort of train on different kinds of data sets. Okay, so this is some sense of what Wolfram language can do sort of running inside your computer. There are lots of different areas that it covers. lots of different kinds of things we can do here. The thing that perhaps I should show you is kind of how do you take all these things that you can compute, whether it's about financial data or whether we've got data on all kinds of things. If you say something like, a left femur, it'll know that that's an anatomical structure. Let's say we want the mesh region for a left femur. Okay, so there's a sort of CAD version of a femur that we can do computations on and so on. So lots of different kinds of, thousands of different domains of knowledge that we've been sort of collecting and curating data on for the last decade or more. But the next question is, okay, so this is stuff that you can do kind of on a desktop. How do you deploy this and actually use it in the cloud, for example? So there's a very simple way to do that. We have just the function called cloud deploy, and let me make a very simple app. And I'm going to use, so one of the features here is that there's a lot of natural language understanding going on. It's the same thing that we would use in the case of Wolfram Alpha to understand, all sorts of random queries that come in from Siri and so on. Here I just asked it to generate a piece of code, and this should be instantaneous. Why isn't it? Who knows? Okay, there we go. So that just created a piece of code from natural language, and I can go and say, add a green background to this, and that again should sort of instantly be able to create code from natural language. The natural language is particularly useful when you're dealing with things that come from sort of people in the outside world interacting with applications and so on. I don't know why this is so slow, but in any case. Okay, so let's say here we want to create a simple app. So let's have an app which takes we're going to make it a form, an app that's based on a form, and let's say we're going to have that form be, take the name of an animal, and it's going to show us an image of that animal. Let's magnify it a bit. Okay, let's say we're going to show it on the web as a PNG. Okay, let's actually make the permissions for this public. So I'm going to create a public little web app here. So okay, so we run this, and now we get a URL here. We go to that URL, and now we've got this little application where we can type in, let's type in otter there, for example, and now we'll go and we get a picture that was based on this code that we just wrote. We can change the code if we want to. We could say, rotate the thing through a certain angle, and we can then say, put in another field here that says, give the angle. We can make this a slider if we want to. Let's just make this a regular field that just says, give us, put in a number there. Now we'll make a new app, so to speak, that has an animal and an angle. This app also deploys on mobile, so so you just bring that up on your phone. If it had an image that it was taking in as input, those fields would turn into take an image type things. We can also take this, and instead of making it be a form, we can make it be an API. So now we've got, this will now generate a web API. The web API will just give an error if we don't give it parameters. So we have to give it, animal equals tiger, ampersand angle equals 3 or something. And now it will then run this API and generate a picture of a tiger. Okay? So now you can take that API and you can embed it in any piece of code that you have. So if we say, let's say, give me the embed code for that API for Java, for example, and it'll just give us the Java code that we need in order to embed the API in an external program. So you can do that running the, so you simply you can write this tiny little piece of code, use that as something to create an API that runs against our cloud, and then put that API into your external program to do whatever you want with it. You can also take the interface that we have here and deploy that. So if I say cloud deploy, let's say a manipulate of, I don't know, let's make a simple plot here. We could say, let's say something like this. Okay, so now this is going to take a plot that we have. Let me make the permissions public so I don't have to worry about logging in. This is now going to deploy an interactive little user interface here. Oh, come on. Wake up, web. Okay, there we go. Okay, so this will now be an interactive thing that can run. You can embed in any website, and you can run that. It's running against our cloud, and it's pretty zippy actually when the web is behaving properly. You can also, let me just show you another thing, you can actually take the whole user interface that I've been showing you, and you can go here and go to our development platform, and you can just go and say, create new notebook. I'm not even logging in here, and you can start doing computations and creating code right here in a browser. And you can go and deploy, you can actually, for free and without logging in and things, you can do some deployments that don't last very long, but you can kind of get started with that. Okay, so I'm going to run out of time in a moment, so I would just want to finish off mentioning a few other things. So kind of the idea here is, this is a way, our idea is to set things up so that we built as much knowledge about computation and about the world as possible into the language. We've automated as much as possible about how to compute things and how to deploy things. And I might mention that one of the things that we've also done a lot of automation on is Internet of Things kinds of things. There's a thing called Wolfram Data Drop, which is a thing that allows you to take, let's see, what's a good example here? How about that? That's so this is something where I have, this is something from my house here. Let's just see what happens. This is the temperature of a hot water tank at my house, and it's got some sensor on it, and that's pushing data into, okay, that was from a while ago, I guess. That's pushing data into our cloud, and now I can do whatever analytics I want on this data, and we have all sorts of fancy analytics. And I could then take this and put it into an app, or set it up as an API, which I can then call from another program and so on. So I see this as being from one of the things that, so the idea is make as high as possible a level of automation in the programming language so that the humans can get to figure out what they want to do and get the computer to deal with it as automatically as possible. One of the interesting kind of side applications of this is to education. One of the things that's now happened is with this language, we've kind of got convergence between the language and system that kind of the fanciest R&D folk in the world use with the kind of thing that you can realistically teach to kids. And so I've been sort of interested in how do you take this language and how do you make it sort of a really good educational experience to teach not just sort of the engineering of programming, but kind of the idea of computational thinking. And so, for example, one of the things we have now, a thing called Programming Lab, which is intended for kids. It's the exact same technology and the exact same system that's intended for software developers, but it's intended for people who are just starting to learn programming. It's kind of an interesting exercise. I wrote this book, which you can find free on the web a few months ago, sort of an interesting exercise for something like mathematics. There's been 1,000 years of history to figure out kind of what's the sequence in which you teach the concepts. We don't have that for computational thinking, but I think we now have the raw material to teach computational thinking very broadly to people. And I think not only can we teach computational thinking to lots of people, we can also now expect to use computational thinking in a much deeper way to do much more algorithmic kinds of things in the world of startups and so on. And I hope some of you will be interested in this. We've seen just this year really dramatic kind of absorption of the things that we're doing in the startup world. I think we even have a booth here, and I'm going to be wandering around there, and I don't think there's time for questions here, but I'll be happy if people come by our booth. I'd be happy to try and personally answer questions, and there are probably some people there who can show you about things that we've been doing as well as me. So thank you very much.